Welcome to today's class. In today's class, we are going to be considering or starting the series Electrolysis. Today, we'll be doing lesson 1. Lesson 1 of electrolysis is all about the terminologies used in electrolysis. The first term we are going to consider is the definition of electrolysis. We are going to be looking at the definition of electrolysis. Then, after that, at the end of the class, you should be able to describe the following. Number 1, you should be able to tell what electrode is. You should be able to tell us what electrolyte is, and you also should be able to describe electrolytic cell. So at the end also, we are going to be differentiating between electrodes, which is anode and cathode, in the process of the lesson. Now let's look at the meaning of electrolysis. Electrolysis is the process whereby chemical decomposition occurs when an electric current is passed through an electrolyte. You can also put it in the other way around by saying electrolysis can be defined as a chemical decomposition of a substance by passing electricity through it. In either case, there is a chemical compound, there is a chemical decomposition, and then we also have the other variable, which is passing electricity to it. And in this process, the electrolyte is decomposed into its component ions. Now, let's look at our second term, which is electrodes. Electrodes. When we talk about electrodes, electrode can be in the form of a rod. It can also be in the form of a plate, or it can be in the form of a wire that allow current to enter or leaves the electrolyte. That is the function of electrode. So, in simple terms, electrodes are conductors in the form of wire, rods, or plate through which an electric current enters or leaves the electrolyte. Okay, we have two forms of electrodes, and these are the cathode and the electrode. The cathode and the anode, rather. The cathode and the anode. Now, you are going to pause the video and try to differentiate between cathode and anode. You can pause the video now. Welcome back. Now, what are the differences you identify? Number 1, you are going to use this to mark your answer. 1, anode is positive, and then cathode is negative. Oxidation occurs at the anode, while reduction occurs at the cathode. Electron leaves the electrolyte or the cell through the anode, while electron enters the electrolyte or the cells through the cathode. So these are basically the various ways we can differentiate between anode and the cathode. While anode is positive, cathode is negative. Oxidation occurs at the anode, reduction occurs at the cathode. Electrons enter the cells or electrolyte through electron leaves the cell through the anode, and then electron enters the cells through the cathode. So these are the various ways you can differentiate between anode and the cathode. Now let's look at our next term, electrolytes. When we talk about electrolytes, electrolytes are compounds. And these particular compounds, they are ionic in nature. That is, they are ionic compound, electrovalent compounds. And as a flashback, let's look at the properties of this compound. They are soluble in water, that is, they dissolve in water to produce ion. They are soluble in water to produce ion. And because they produce ion in solution, when you dissolve them in water or when you melt them, they conduct electricity. They conduct electricity. So, having seen these properties of ionic compound, we cannot say an electrolyte is a compound which conducts electricity in a molten or aqueous state and is decomposed in the process into the component ions. Every electrolyte is made up of two ions. They are anions, from the word anode ions, and they are also made up of cations, which means cathode ions. You see, anions are negative ions, while cations are positive ions. So anions migrate to anode, which is positive because they are negative. Cations migrate to the cathode, which is negative because they are positive. So in every electrolyte, apart from organic acid, the cations form the first part of the compound. Take for example, calcium chloride. You see, if you break this into the ion, calcium ion and chloride ion, the first part, which is calcium ion, give us the cation. Then the second part, which is chloride ion, gives us the anion. So every electrolyte, when melted or dissolved in water, conducts electricity. And when you pass electricity to it, is decomposed into the component ion in the process known as ionization. Anyway, when we get to under the ionic theory, we'll talk more about that. Okay, electrolytes may be strong or weak. I want you to differentiate between strong and weak electrolytes. I'm going to give you a clue to that. Electrolyte generally are acids and alkalis, or let's say yes, and alkalis or bases, as the case may be. Alkalis are bases, but not all bases are alkaline. Okay, now we also have salts. These are the three major substances that make up the electrolyte. Why did I bring you here to talk about acid and alkali? Because I remember you should have learned strong acid and weak acid. You should have learned strong acid, and you should have also learned weak acid, strong acid and weak acid. Okay, if you can remember your definition of strong acid, it is similar to the definition of strong electrolyte. The same way with alkali, both strong and weak. Alright, so you can pause the video and try to recall what strong acid and strong base is, weak acid and weak base. Then you can now come back and get the correction at the end, so you can pause the video now. Welcome back. Strong acid or strong electrolytes are substances that dissociate or ionize completely in water. Now let's come to electrolyte proper. Strong electrolytes are electrolytes that ionize completely when you pass electric current through the molten or aqueous form. Strong electrolytes, they are electrolytes that ionize completely when you pass electric current through the molten or aqueous form. Then when we come to weak acid are acid that ionize partially in water. Then let's relate it to electrolytes. Weak electrolytes are electrolytes that ionize partially when you pass electric current through the aqueous or molten form. So that is the difference between strong and weak electrolytes. Let's look at the next part of this lesson 1. Next part of lesson 1 is telling us about non-electrolyte, which is opposite electrolyte. These electrolytes are also compounds, particularly covalent compound. They are covalent compounds. And if you can recall the properties of covalent compound, they are insoluble in water. They are insoluble in water. So because they are not soluble in water, to produce ion, they do not conduct electricity. They do not conduct electricity. So these are the properties of non-electrolytes. So they are non-electrolytes because they do not conduct electricity. And they do not conduct electricity because they are insoluble in water. No mobile ion. This reminds me, going back to electrolyte, please, if you can recall my definition, I told you that there are substances that allow the passage of electricity through their molten or aqueous form. Note, they don't conduct electricity in their solid state. I'm talking about electrolytes because there are no mobile ions. There are no mobile ions, so they won't conduct electricity in their solid state. They can only conduct electricity in their aqueous or molten state. And I've told you the examples are acid, alkalis, and salt. Now, coming down to non-electrolytes, we have covalent compounds such as hydrocarbons, which is ethane, methane, up to decane, and the others. We have urea, we have benzene, we have ether, we have sugarcane or cane sugar, and then we have tetrachloroethane, even monochloroethane or dichloroethane, trichloroethane. They are all examples of non-electrolyte, and they won't conduct electricity because they have no mobile ion, because they are insoluble in water. Let's proceed to the last part of the lesson 1. Last part of lesson 1 is electrolytic cell. Electrolytic cell. Before I come back to this, I will take you to the next activity so that you are going to look at this diagram carefully. Just look at the components. We have the cell, we have the variable resistor, which is the rheostat, we have the ammeter, we have the key. These are components of a circuit. We have the electrode, which is cathode, and then we have anode, which is our carbon, and then copper as our cathode. Then we have a conductor, and then you have seen clearly our anode is positive and our cathode is negative. Then you have the electrolyte, the solution that conducts electricity. So looking at all these components, taking you to the next activity, which you will pause the video to do, is to describe electrolytic cell. You have to describe electrolytic cell. Looking at this diagram, you have to describe the electrolytic cell. So how will you describe electrolytic cell? You can pause the video and come back and get the correction. Welcome back. When we talk about electrolytic cell, it is the assembly. It is the assembly of the conductor, the electrodes, and the electrolyte in a container to make a circuit. And that circuit is what we refer to as a cell, electrolytic cell in particular. The assembly of the electrode, electrolyte, and conductor in a container to make a circuit. So that is the electrolytic cell. All right. Now, having seen that, that actually brought us to the end of lesson 1 in the electrolytic series. So I'll be expecting to see you in lesson 2. Have a nice day.